Hello, this is Team 9. Last week, we talked about water treatment. This week, let's talk about the construction of the underground structure. When creating an underground space, our goal is to build it safely and efficiently by using appropriate structures and construction methods tailored to the space's purpose and objectives. If we fail to do so, there is a risk of the structure collapsing or not being used efficiently. This video shows the recent collapse of an underground parking lot at a new apartment building construction site in Komdan New City. If a similar incident occurs at our site, it would result in significant losses in various aspects. As we arrived at the site and opened the construction site gate, we immediately noticed the formwork for column and beam installation. The structure used for the underground floor was a rigid frame structure consisting of columns, beams, and slabs. Rigid frame structures are one of the representative structural types used for underground floors, along with flat slab structures. First, let's take a closer look at these two structural types. So, what kind of structure and construction method is used for the underground floor at our site Hanyang-Sujain River Pine? Mushroom construction is a form of reinforced concrete structure in which the horizontal structural member supporting the load, the beam, is absent and the slab is directly connected to the vertical member, the column which supports the load of the building. This structure has the advantage of being more economical than rigid frame structures in various aspects such as excavation due to its lower floor-to-floor height since there is no beam between the column and slab. A rigid frame structure refers to a structural system where horizontal members consisting of slabs and beams are connected to columns like a frame. Compared to a mushroom structure, this structure has a stronger resistance against bending and shear forces since the forces are transmitted from the slab to the column through the beam, and it also allows for fewer columns to be placed, increasingly parking space efficiency. The main reason we chose a rigid frame structure instead of a mushroom structure, which is more economical, is because of the efficiency of a low floor-to-ceiling height is significantly reduced due to the site characteristics of our project. We designed our apartment to have a deck-type base parking lot that allows for entry from both the outside and the first floor by utilizing the terrain's height difference. Consequently, we needed to lower the basement level enough to allow the entry from the outside road to the first basement level. And since this height was sufficient for our rigid frame structure at 3.6 meters, we chose a rigid frame that could provide both stability and space efficiency over the cost savings of a mushroom structure.
So, how is Hanyang-Sujain applying the rigid frame structure in construction? The on-site installation process is being carried out in order of foundation, column, beam, and floor. The location where the entire installation process can be seen on site is the site for buildings 105 to 108, which has completed installation up to the second basement level. The reason why this site progressed faster than others is that it is planned to be the highest building. So, the foundation installation was carried out first. Therefore, it was possible to observe the construction process through Gate 3 and 4, which are located near this site. First, the columns. The column installation process can be divided into three main steps: placing the reinforced bar vertically, formwork installation, and concrete pouring. The important thing to note here is that the concrete is poured in two steps to prevent the pressure generated by the concrete when it is poured into the formwork from being too high and causing the formwork to burst. Fortunately, when we visit the site, we were able to observe all three steps of column installation process because the progress of the installation process was different for each building site. Secondly, beam. The important point of rigid frame structure construction is that we have to install the beam. After the installation of columns are completed, the beam reinforcement is connected to the column reinforcement and placed in the formwork, and then concrete is poured into the formwork. Unlike columns, beams are installed all at once, and concrete is poured from the both ends toward the center, with the principle that the poured concrete should not move horizontally in the formwork. At our site, we were able to confirm that completion of the beam installation process up to the formwork stage for the basement of Building 108. Lastly, slab. When pouring the slab, caring must be taken to ensure that the reinforced bar is not disturbed, especially the position of the reinforced bar placed above the beam. If it has moved, it must be reconnected. Also, concentrated concrete pouring in one area should be avoided. And when pouring around areas with dense electrical equipment and piping, a vibrating machine should be used to sufficiently compact the concrete. At our site, the basement floor of Building 106 has been completed, and we can see the installation of columns being carried out on top of it. There is one thing to examine here. At our construction site, we have devised one countermeasure to prevent collapse due to beam deflection when constructing the beams and floor. It is the reinforcement of full staging method. According to the deck design standard, full staging method reinforcement is required when the distance between columns are 4,000 millimeters or more. But at our site, full staging method reinforcement was carried out from 3,600 millimeters or more to further ensure stability against collapse before and after the concrete placement. This is the picture that shows where the full staging method reinforcement was carried out at our site.
The processes so far do not occur simultaneously throughout the entire construction site. In the construction site, situations progress differently in each section, and these processes are quite complex. The biggest feature of our site is the terrain with the level differences. Due to the level difference of this terrain, there are many factors to consider, such as the number of floors per building and access roads under construction. So, how did Hanyang plan the basement construction process?
Hanyang started placing the foundations for buildings 106 and 107 in February of 2023, completed the foundation work for buildings 105 and 108 in March, and began the construction of the basement levels for buildings 106 and 107 in April. In May, we are currently working on the foundation work for the entire area, except for Building 102, which is in the access road trans Gate 1 and Gate 5, and the construction work the basement levels for Buildings 105 and 108. Once the foundation work for the entire area is completed, we will move on to the construction of the basement levels.
In August, we plan to complete the basement levels for all 11 buildings in the access road area, and we will relocate the existing entrances to gate number 2 and gate number 4 to change the vehicle traffic line to the upper level of the basement. Then, in September, we will complete all basement levels, including building 102, and proceed with the construction of floors 1 through 14 for each building. The final structural completion is scheduled for April of 2024. Although Building 102 started about 6 months later than the other buildings, it has fewer floors and will only have a difference of 1 to 2 months in completion time. This time, we have looked in detail at the basement structural construction process. Next week, we will discuss the tower crane, which is essential in the construction process. Thank you.